That's the best way to do it. The B, instead of going down, goes up now.
Why did you flip the blue and flag the hot bottom?
To subtract, A is still the same, right? But B is a negative B. Here's positive B, here's negative B.
Negative is automatically on top.
No, just the way B happened to end up. You always put them tip to tail. B, instead of being down, is now up. Yeah? Does that make sense? Okay, so the order officially doesn't matter. If you were good enough with a protractor, you could have ended up in exactly the same spot. Yeah? And this is very good news for us. This means that... Can we be quiet? Can the private side conversation stop? This is good news for us. This means that vectors are just like numbers. 2 plus 3 is the same as 3 plus 2. Yeah? Isn't that a wonderful thing? Okay? So this makes life a lot easier for us. Okay? And then the final thing is that there's two different types of vectors. And you guys, I think, probably came up with these two different types. All on your own. I'll bet. Okay? So you came up with a set of directions. A better set of directions, didn't you?
Yep.
Yeah. So did anybody come up with, it's just one line. It would have been on this map that I gave you. It would have been just one of those. And it's got an angle. Does somebody have one of those they want to share with me? Does somebody want to share one of those with me? The better set of directions. What do you got? No, just your better set. You condensed it down to a better set. Centimeters. 7.7. Yeah? Oh, 233. That's so close. Could I have your attention, please? Come back. Come back. So this is an example of a vector that's called an angle magnitude vector. That's what I'm going to call it. I don't know if anybody else calls them that, but there it is, right? An angle magnitude vector, and this is very difficult, has an angle and a magnitude. Yeah? That's why it's called an angle magnitude vector. Yeah? Okay. Now, did anybody come up with a set of directions, a better set of directions that did the same thing as all of those directions that you had, that didn't use a single angle, because angles are a pain? You have two directions and you didn't use a single angle. Did anybody do that?
Just turn your paper sideways.
Did anybody have two directions? Not a soul. This rarely happens. Yeah. What? That's what we're doing. Did anybody come up with two directions? Your better set of directions on your little sheet was two directions. Did anybody have that? What do you got? Tell me, what do you got? Okay, so let's say minus 3.4 centimeters in the x direction and minus 4.1 centimeters in the y direction or something like that. Did anybody come up with a set like that? You did. What is it? Okay, so minus 6 centimeters in the y direction and? Okay. There we go. So this vector, and you know what they did? They just said, look, the protractor is a pain in the butt. I don't want to use it, so I'm going to just go. I'm going to tell them how far in the x, how far in the y. Yeah? Does that make sense?
So
This type is called a vector component. Yeah? Yeah? Those are our two types. That's all we need to understand. There are two types. And this type is your friend. This one's our friend.
So that one's like red over red.
Struggling to have a good attitude here, guys. This guy is our friend. Okay, so 5 to the left, 6 down. What we're describing is this vector here. Okay? We're describing a vector that is over 5 and 6 down, like that. It really is this guy. That's really what we're doing, right, as we're going from here to here, but we're describing in terms of how far X, how far Y, and what direction. Yeah? Okay? So these guys are our friends. Whenever we get one of these, we want to turn it into a thing like this. Okay? So this is our first task. This is what what I'm going to show you. This is your homework for tonight on the vector sheet, is 1 through 6, is how to go from this kind of vector to this kind of vector. Okay? Now, this is kind of funny. If you look at this sheet, at this thing right here, okay? This is the same vector written both ways. Okay? So 5 centimeters at 36.87 or something like that, right? Looks like that. And then this is the components, 4 over and 3 up. And 3, 4, 5 could be a right triangle, couldn't it? What? Right, so I'm going to show you how to take this and make that, and then I'm going to show you how to take that and make this. Right, these are all skills that I haven't showed you yet, and that's why you don't get it. Yeah?
On the vector sheet, are we matching up the angles?
No. You are going to actually calculate those components. You're going to take your calculator, doing what I'm about to show you, yeah?